In this video, we'll be solving equations quadratic in form, but we won't use substitution to perform our factoring. I know that this equation, x to the fourth minus 10x squared plus 9 equals 0, is quadratic in form because I have it written in descending order, and the exponent on my second term is half the first, and the third term is a constant. Since this is quadratic in form, I should be able to factor it as normal. This is a quadratic trinomial with a leading coefficient of 1. I'm going to go right to the parentheses, but the difference here, instead of having x's in first position, we're going to have x squareds in first position. That way, when I multiply this out, x squared times x squared is going to give me my x to the fourth. Now we're looking for two numbers that multiply together to give us a positive 9, but add together to be a negative 10. Negative 9 and negative 1 work. These factors are quadratic. We always want to try to factor them further. We recognize x squared minus 9 to be the difference of two squares. This will factor into x plus 3 times x minus 3. Looking at x squared minus 1, again, we have the difference of two squares. This factors into x plus 1 times x minus 1. All of my factors are linear. I'm going to go ahead and use the zero product property and set each one of these factors equal to 0 and finish solving. Solving each of these linear equations, we get x to be negative 3, x to be positive 3, x to be negative 1, and lastly, x equals positive 1. There were 4 solutions to this equation. You know how many solutions you're supposed to have based on the degree of the equation. This was a 4th degree polynomial, so we should have 4 solutions. Next, let's solve y squared times 4y squared plus 17 equals 15. The first thing we want to do is multiply things out. We can't tell what kind of equation we have exactly when we have the parentheses. So y squared times 4y squared gives me 4y to the fourth. Y squared times 17, that's plus 17y squared, equals 15. I'm going to set this equation equal to 0. We see that we have a 4th degree equation that is quadratic in form. My second exponent is half the first, and my third term is a constant. I can proceed with factoring this as I would any other quadratic trinomial. The leading coefficient is not 1, so I'm going to use my x method to factor. A times c in the top, b in the bottom. We're looking for two numbers that multiply together to be negative 60, but add together to be positive 17. Positive 20 and negative 3 work. We'll use these numbers to strategically uncombine our middle term. We get 4y to the fourth plus 20y squared minus 3y squared minus 15 equals 0. We'll factor by grouping. GCF out of the first two terms, 4y squared. That'll leave us with y squared plus 5. The GCF out of our second two terms is negative 3. That leaves us with y squared plus 5. There's the common binomial factor that we need to factor out. Y squared plus 5. 4y squared minus 3 is my second factor. These factors are both quadratic, so I'm going to try to factor them further. Y squared plus 5 doesn't factor, neither does 4y squared minus 3. Since I can't factor them further at this point, I'm going to go ahead and apply zero product property and set each of these factors equal to 0 and solve from there. With both of these equations, I need to select a technique for solving quadratics other than factoring. Both of these equations have a quadratic term and a constant term, but no linear term. Square root property is going to be the best technique here. I'm going to isolate what's squared by subtracting 5 from both sides. Next, we apply square root property. Take the square root of both sides. On the left, the square and the square root cancel out, leaving us with y. And on the right, we get plus or minus the square root of negative 5. We want to simplify our radical. We have a negative underneath of a square root. We know that that's going to become an I out in front. And the square root of 5 does not simplify further. Our first two solutions are y equals plus or minus I square root of 5. We'll use square root property again for our second equation. I need to isolate what's being squared. We'll start by adding 3 to both sides and then dividing by 4. Now we're ready for square root property. Taking the square root of both sides, on the left, the square and square root cancel out, leaving us with just y. And on the right, we'll have plus or minus the square root of 3/4. We want to simplify the square root of 3/4. Anytime you have the square root of a fraction, you want to break it up into the square root of the numerator over the square root of the denominator. It's going to give us y equals plus or minus the square root of 3 over the square root of 4. And then simplifying the numerator and denominator separately, we get y to be equal to plus or minus the square root of 3 over 2. This equation was fourth degree. We end up with 4 solutions, plus or minus I square root of 5 and plus or minus square root of 3 over 2.